Somewhere in a locked drawer in a Tasmanian museum, a set of bones sat for 86 years, mislabeled, misunderstood, and completely ignored, while the world outside told itself a story that turned out to be only half true. And in a quiet office thousands of kilometers away, a scientist ran a set of numbers through a model that was never supposed to be controversial. He was not hunting for a monster. He was not chasing rumors in the bush. He was simply trying to answer one dry statistical question: when did the sightings actually stop meaning something? And the answer that came back out of that model did not match the date carved onto plaques, printed in textbooks, and taught to every schoolchild in Australia. It landed decades later than anyone expected, and once he saw it, he could not unsee it. This is the story of an animal the world buried in 1936, and the quiet, uncomfortable evidence suggesting we buried it far too early. Every extinction needs a clean ending. We like our tragedies to have a last page, a final photograph, a date we can point to and say, this is where it stopped. For the Thylacine, the animal most people know as the Tasmanian tiger, that date has always been the 7th of September, 1936. On that cold night in Hobart, the last captive Thylacine, kept in a private enclosure known as Beaumaris Zoo, was accidentally locked out of its sheltered den. It spent its final hours exposed to the freezing air, and by morning it was dead. That single event became the symbolic full stop on an entire species. It is remembered every year now, because Australia turned that date into National Threatened Species Day, a permanent reminder of what carelessness can cost. But a date chosen to represent a tragedy is not the same thing as a date proven by evidence, and that gap between symbolism and fact is exactly where this story lives. To understand why that date might be wrong, you first have to understand what kind of animal we are actually talking about, because almost everything about its common name is a little bit false. The Thylacine was not a tiger, and it was not any relation to one. It was a marsupial, a pouched mammal, distantly related to kangaroos, wombats, and Tasmanian devils, not to any cat on Earth. Early European settlers looked at the dark stripes running across its lower back, and simply reached for the most intimidating striped animal they could think of, and the name stuck. Its actual scientific name, Thylacinus cynocephalus, translates roughly to pouched dog head, which is a far more accurate description. It moved like a dog, it hunted somewhat like a dog, and from a distance in poor light, early settlers sometimes mistook it for one. But get closer and the illusion collapsed immediately. Both male and female thylacines carried a pouch, something no dog has ever done. The male's pouch was a partial fold of skin that protected sensitive anatomy while moving through dense undergrowth, and the female's pouch opened backward, toward the tail, rather than forward like a kangaroo's. Its tail itself was nothing like a dog's either. It was thick and stiff at the base, tapering to a point, held out rigidly behind the animal almost like a kangaroo's counterbalance rather than a loose, wagging appendage. And then there was the jaw. The thylacine could open its mouth to somewhere near 80 degrees, one of the widest gapes ever measured in any mammal that has ever lived. In the handful of surviving film clips we have, that yawn is unmistakable, almost unsettling to watch, a slow mechanical unfolding that looks less like a yawn and more like a hinge coming loose. Here is where the story takes its first strange turn, because despite that enormous, frightening gape, the thylacine's actual bite was weak. Its jaw was long and narrow, built more for opening wide than for generating crushing force. Later biomechanical studies of its skull suggested an animal built to take relatively small prey, birds, possums, smaller wallabies, not the kind of animal capable of bringing down and tearing apart a full-grown adult sheep. That detail matters enormously, because the entire justification for wiping this species out rested on the claim that it was slaughtering livestock across the island. When British colonists began establishing sheep farms across Tasmania's wet interior in the early 1800s, an estimated 5,000 thylacines still moved through the island. That was not a huge population, but it was a stable one, a species that had already survived the loss of an entire continent. The thylacine had once ranged across mainland Australia and New Guinea, before vanishing from the mainland somewhere between 2,000 and 3,000 years ago, most likely outcompeted by the dingo, a more social, pack-hunting predator that arrived from the north. Tasmania, cut off from the mainland by rising seas and never reached by the dingo, became the thylacine's last refuge, an accident of geography that kept the species alive while its mainland relatives disappeared entirely. That refuge did not last. When colonial sheep farms began losing livestock to disease, poor husbandry, cold, and wild dogs, the blame fell almost entirely on the thylacine, an animal that was, at most, an opportunistic scavenger of carcasses it had not killed. In 1830, a powerful pastoral company operating in the island's northwest introduced the first bounty for dead thylacines. In 1888, the Tasmanian government formalised the slaughter, offering £1 for every adult thylacine killed and 10 shillings for every pup, a policy that did not simply target the species, but specifically targeted its ability to reproduce. Over the 21 years that government bounty operated, more than 2,000 payments were officially recorded, out of a starting population of roughly 5,000 animals. The true number killed, including unreported and unclaimed deaths, was almost certainly higher. Then, as the population was already collapsing under the weight of organized hunting, something else moved through it. Around the 1890s and into the early 1900s, observers began reporting animals found dead with no visible wounds, thin, weak, and sick. The leading theory points to a disease, possibly a form of canine distemper introduced by the dog settlers had brought with them, sweeping through a population that no longer had the numbers to absorb it. A healthy, abundant species can survive hunting pressure and disease separately. A species already fragmented and reduced by decades of bounty hunting could not survive both at once. By the time the government bounty finally ended in 1909, the thylacine was no longer simply declining, it was collapsing toward a point of no return. The wild population's last widely accepted trace came in 1930, when a farmer in the island's northwest shot a thylacine he found near his property. A photograph exists of him afterward, holding the animal by its stiff tail, an ordinary picture of what he believed was an ordinary problem solved. The moving footage we have of this animal, across its entire existence on film, adds up to roughly 3 minutes total, most of it shot at Beaumaris Zoo in the years before that final death. It is black and white, silent, and grainy, and in not a single frame is there ever more than one living thylacine on screen. We never see a pair. We never see a family. We only ever see the last of something, pacing alone behind wire, long before anyone understood that is what they were filming. In May of 2020, Australia's National Film Archive released 21 seconds of previously unseen thylacine footage, shot in 1935 and buried for 85 years inside a tourism film advertising Tasmania to travellers. It was new to us. It was not new to the animal. She had already been dead for 84 years by the time the world finally saw her walk. That is where the official record ends, and for most of the last century, that has been the entire story. Last confirmed wild kill in 1930. Last captive death in 1936. Extinction formally declared by the International Conservation Authority in 1982, and the species finally removed from Tasmania's own protected list in 1986, 50 years after that final cold night, with no confirmed sighting recorded in all that time. 50 years of silence became the proof. No confirmed sightings meant nothing was left to see. But silence is not the same thing as absence, and this is where the case genuinely starts to complicate itself, carefully, quietly, in academic journals that almost nobody outside the field ever reads. Over the past decade, researchers studying extinction timing have begun applying statistical extinction models, mathematical tools originally developed to estimate when other elusive or possibly extinct species truly disappeared, to the full historical record of thylacine sightings. These models do not chase individual claims or grade photographs for authenticity. Instead, They treat the entire pattern of reported sightings after the official extinction date as a signal to be analyzed. A population that is genuinely gone tends to produce a sighting record that is mostly noise, misidentifications, and wishful thinking, one that fades quickly and randomly. A population that persists in low numbers, even if never conclusively photographed, tends to leave behind a signal that tapers off more gradually and more coherently over time, weighted toward sightings from people with genuine field experience. In 2023, a researcher specializing in environmental modeling applied exactly this kind of analysis to more than 1,000 recorded thylacine sightings spanning the decades after 1936. The result did not point back to 1936 at all. The modeling instead suggested a most likely true extinction window stretching from the late 20th century into the early 2000s, meaning the species may have persisted, undetected, in Tasmania's dense and largely inaccessible wet forests for 50 or 60 years longer than the official record admits. That does not mean the thylacine is alive today. The researchers behind this kind of modeling are explicit that the species is almost certainly extinct now. What the analysis suggests is something quieter, and in some ways more haunting than a surviving population, an animal that outlived its own official funeral by half a century, moving through country too remote and too dense for anyone to ever confirm it, while the rest of the world had already closed the book. This is not a claim that a living thylacine is currently padding through the Tasmanian bush waiting to be caught on a trail camera. It is a statistical argument about probability and pattern, built from the same kind of modeling used across conservation science to estimate extinction dates for other elusive species. And it comes with real limits. The field's most prominent skeptic, a researcher who has spent decades examining the majority of reported thylacine sightings personally, has repeatedly demonstrated that most claimed encounters have far more mundane explanations, especially confusion with the pademelon, a small wallaby that can resemble a thylacine at a glance in poor light or fast motion. Dense terrain, unreliable lighting, and understandable human hope all combine to produce a steady trickle of sincere, but almost certainly mistaken reports. Any honest accounting of this mystery has to hold both of those things at once: the mathematical case that the species may have persisted far longer than 1936, and the very reasonable skepticism about almost every individual sighting used to build that case. What makes this story even stranger is what happened, almost in parallel, to the identity of that final captive animal herself. For most of the 20th century, the last known thylacine was remembered in books, documentaries, and museum captions as a male, and was even given a name, Benjamin, despite no contemporary record from 1936 ever using that name or identifying the animal's sex that way. It was only in 2022 that historians and museum researchers finally corrected the record. The last thylacine was female. She was never called Benjamin in her lifetime. And her actual physical remains, rather than being lost as long assumed, had spent 86 years sitting unidentified in a museum collection, occasionally handled as an ordinary teaching specimen by curators, who had no idea what they were holding. An entire species' most famous individual spent nearly a century misfiled under the wrong name and the wrong sex, discovered only by accident, decades after anyone thought to look properly. At the same time this correction was unfolding, an entirely different effort was underway in laboratories on the other side of the world, where researchers working on de-extinction technology have been editing hundreds of genes into the cells of a small living marsupial relative, attempting to move closer to something that might one day resemble a thylacine, even if it can never truly be one again. It is a project surrounded by genuine scientific debate about what such an animal would even be, and whether recreating an approximation of a lost species is meaningfully different from simply preserving what remains of the ones we still have. So where does that leave the actual mystery at the center of all this? Not with a confirmed living population. Not with a grainy modern photograph that settles anything. What it leaves us with is a species whose official death date was chosen for its symbolic weight rather than proven by direct evidence, a mounting body of statistical analysis suggesting the true end may have come decades later than the plaques and textbooks claim, and a scientist whose own model handed him an answer he almost certainly did not expect when he sat down to run the numbers. The Thylacine story has always been treated as closed, a tragedy with a fixed ending everyone already agreed on. But the deeper you look into the sightings, the disease records, the bounty ledgers, and now the mathematics of extinction itself, the less closed that case actually looks. Maybe the last Thylacine really did die alone in that Hobart enclosure in 1936, and everything since has simply been the noise of a grieving country refusing to accept an ending. Or maybe, in the wettest, darkest, least accessible corners of an island most people will never set foot in, something with an 80-degree gape and a stiff kangaroo-like tail kept moving through the undergrowth for another 50 years while the rest of the world had already stopped looking. We may never know for certain which of those two stories is true. But the data, for the first time in nearly a century, is no longer entirely on the side of the official one. What do you think?